Time for more Earth Science. This is Norris Teaches Science with me, Mr. Norris. Another Earth Science video, and today we're going to talk about scientific method. Even though this is not a distinctive Earth Science topic, we are going to cover it because this is a science class. Well, science video. So by the end, I can explain how to obtain knowledge through the scientific method. I say obtain knowledge. If you refer back to the first video in the Earth Science series, I said science was a system of knowledge and the methods used to gain that knowledge. So here's the method, known as the scientific method. It's an organized plan for gathering, organizing, and communication of information. Somehow we're going to get information, we got to give it to other people, but we got to organize it at the same time or keep it in a unique way. The goals of the scientific method is to solve a problem or you're going to better understand something. It's either or. One is to solve something, one is just to know more about it. So here are some simplified steps to the scientific method. Most of them are about the same. Some people add a little bit here or there. So the first thing you have to start with is your problem or your question. What do you want to find out? What is the question? You need to go. You have to state your question. State what you want to do. Then you're going to research the topic or topics. You're going to learn more about the topics, what it's like, what about this, what's related to this. Are there any information out there already to help you answer the question, or is it you just have some basic knowledge you need to know more? Then you form something called a hypothesis, and we'll talk more about that. After the hypothesis, you're going to have your experiment where you actually do the experiment, you actually test your hypothesis. During your experiment and after the experiment, you're going to collect and analyze your data. Data comes in multiple forms. Some of it is written form, some of it is number form. And then after that, you're going to make a conclusion. During your conclusion, you say if you were right or wrong. If you're right, why you're right. If you're wrong, how could you make your hypothesis right? Then you usually have to repeat the whole experiment process multiple times so you have more data and more collaboration between people. Now, I said a hypothesis, but let's talk about the evolution of a scientific idea. If you don't know, evolution just means change over time. A scientific idea first starts off as a hypothesis. It's an educated guess. You have to say this is what's going to happen, but you have the education from the research. The second thing is the theory. This is an intensely tested hypothesis, means there's a lot of data to it. And it says this is what's going on. Not all the scientific community accepts it, but that's because a theory can be proven wrong. When new data comes available, it can make a theory have to be modified and restated. We used to have the theory of continental drift, and then more data came through, and that changed it to the theory of plate tectonics. The last thing is a scientific law. And scientific laws are 99% true. And it summarizes a pattern in nature. You think of like the law of gravity. We know if we have a pin on Earth and we drop it, it's going to drop to the ground. Now you could disprove the scientific law if somehow you found a way to drop that pin and it doesn't fall, it just floats or drops up. Over here in this picture, this is Newton's second law of motion, force equals mass times acceleration. But just a little bit about the scientific method. There's more to it. As you go on in high school, you're going to learn more about the scientific method. You probably already know a little bit more about it from middle school or from any other science you learned. But I hope you learned a little bit something today. And this is Mr. Norris, and I am signing out of this video.